Hi there and welcome back. So today I've got a video for you about encapsulation and about datasets. So the purpose of the video today is to explain the concept of breaking up your jobs into smaller pieces so that you can work on them individually. This will make you more agile. It'll also allow you to iterate those kinds of things. So if you've got an ingest job that is just an ingest job, you can size your cluster specifically to that. Once you've done that, you're finished and it's just stable and it's going to work, and then you can work on the next thing. If you try to make an end-to-end pipeline, then you're adding complexity every time you make a change to that. Every time you add another layer of processing to that, it becomes more complicated, and complexity makes things more expensive and time consuming to manage. So ideally you should try to avoid those things. Sometimes it's not possible to avoid that, but you should at least try. Hopefully you'll enjoy the video. If you do, don't forget to hit that subscribe button below. You can now, if you go to davedoesdemos.com, submit questions to me, and I hope that we can start getting a regular cadence going with questions and answer sessions so that I can directly answer some of the queries that you guys have about this technology or about any of the demos that we do. Hope you enjoy the video. Thanks. What we're talking about today is encapsulation and effectively splitting up your data platforms so that you can more easily work on individual components, and so that you can do your governance a little bit easier. What we find is that when people try to do end-to-end pipelines, taking data from several data sources, ingesting it, processing it, modeling it, and then outputting a model all in a single action, then that gets complicated. It makes it harder to share the resources, the data, those sorts of things, and it just adds complexity to something that should be relatively simple. So what you're seeing on the screen at the moment is just a representation of your pipeline being broken up. So in theory, your raw ingest should always just be on its own. Pull the data from a data source, put it into the lake. And as I've said in another video, if you've got something like IoT, then that IoT should be its own kind of system. So even if the IoT system is dumping things onto data lake store or onto a storage account, that would be your primary copy of the data. So that's the thing that you're going to back up. That's the thing that you're going to have data lifecycle management around for that product, for that application. And then you might also have a second set, which would be your kind of data lake raw copy of the data. There's nothing stopping you when you're using IoT Hub or Event Hub from dropping that data into two locations in storage at the same time. So don't think that you have to set up a pipeline to go back into your IoT store and pull the data out separately. You can just dump it into two places, but it's very useful to treat them as separate things just from a governance perspective, so that if you need to delete the data and rehydrate it, you can do that in your raw store, but you wouldn't do that necessarily back on your source data. You wouldn't delete that because that's kind of your source copy. If you're going to reprocess data into your lake, so if you've got a model that consumes that data, you would probably reach back to your raw storage rather than to your source storage. Just conceptually, this will make a lot more sense when you're working on the things to compartmentalize a little bit. In the real world, there are lots of reasons why you wouldn't do it this way, but to explain it to people that are fairly new to the subject, it's much better to kind of think of these things conceptually as individual things. And then once you've ingested your data, that is your data lake proper. So you've got a bunch of raw data sets, and then you're probably going to standardize those into a standardized schema. And this will be your lake schema. So it's fairly light touch, but it would be things like naming everything the same, making sure that like a column for a customer is one of them might have customer underscore name, one of them might be cust name, and things like that. You would want a standard schema so that when people are working from the data in the lake, that they would understand what it is they're looking at, make things easy to find, make things easy to consume. And quite often you're standardizing formats as well, just to make it easier for you to work with downstream. So you might convert everything into Parquet files. you might convert everything into CSV files, depending on the kind of tooling that you're going to use downstream. That standardized stuff is still going to be in your lake, because you haven't really applied a model to it. You've just kind of put it into a place where everything is normalized against one another. Normalized is probably a bad word in the data realm. And then finally, you might have an actual model. So this is where you're getting towards a data mart, a data warehouse, or a lake house is a new term that's kind of cropping up more and more. I don't consider this, as I said in the other video, to be part of the data lake. I consider this to be another product that you're creating from your lake, and you might have 10 or 20 of these for different purposes, each of them with their own model, with their own schema, with their own mixes of data. But it's kind of irrelevant as far as this video is concerned. All we're looking at here is three distinct sets of data, and what you'll see quite often is these are called layers. Quite often you might have a raw layer, standardized layer, modeled layer, or you might have bronze, silver, gold. And when you look at it, those things don't kind of really make sense to be part of the structure of the actual data lake. So when we're looking at data sets, each data set itself is going to have a bunch of governance around it, a bunch of attributes that you can apply to it. And these lead to the way that you're going to treat it, where you're going to store it, whether you're going to replicate it, whether you're going to back it up, and all of those good things. So the first thing that we're going to have for our data set is going to be the data contract. Now, this is the contract with the outside world. This is an idea that comes from programming. So if I make an API, I'll have a contract that says, if you give me these parameters, I will give you an answer. And the answer will be in this format, and these are the things that it's going to do. When we're talking about data, what we're actually saying is, I'm going to provide you with this kind of data. So let's say my data set is customer data. I'm going to provide you with customer data. That customer data is going to include the customer name, the customer address, the customer telephone number, and nothing else right now. And I'm going to provide it daily, and I'm going to update that at 12 o'clock every day, and you're going to get the latest version of that data. That's your contract. So everyone outside of your team is going to know, okay, so if I need customer data, I can go there 12 o'clock every day, and that new data should be there. Or that, I know that I might be coming there anytime, and I'll just get the very latest data if you're updating it every time new data comes in. And that's the contract with the outside world. So nobody needs to know how I've processed that data. All the people outside of my kind of sphere of influence need to know is what I'm providing to them. And if the thing that I'm providing to them is not what they're looking for, they might want to create something new, or they might want to derive something from my data, or they might want to abandon it altogether and go and do something else. And that's kind of the purpose of the contract, is to understand, can I use this thing for the thing that I'm trying to do? Next, what we need to understand is performance. So when I'm putting a data set together, I might need to put it onto a single storage account or multiple storage accounts to make it perform better. I might need to split the data up, partition the data, whatever, to meet performance goals. So IoT might have really, really strict performance goals, whereas data warehouse stuff, where we're just writing a model to disk, then reading it once, performance is less of an issue there. So we might want to use some kind of cheaper storage. We're also going to take availability into account. So generally, your kind of raw data, you're less worried about availability because you're not hitting it constantly, and therefore it's not too big of a problem if it's down. It's not customer facing. That's customer of the data kind of facing. Whereas the actual model data, if you've got a lake house, then availability becomes really important because it's end user facing, and people might be actually querying that in real time to get data. Applications might rely on it, so availability is a really big thing. And we might want to provide DR for those services and that sort of thing. Then next is compliance. This is another big one. So from a compliance perspective, you should understand on a data set by data set basis what what regulations apply to it. So if you've got PII in that data, GDPR might apply to it. And this is kind of important. So from a compliance perspective, I might have data about my customers which is subject to GDPR, but I might have chosen in my data contract to remove the PII before the data gets to the data lake. And that then means that I am compliant with GDPR by not importing that data. I could have a second set of the same data, but with the PII, and it will still be compliant because I've dealt with that compliance. I've made the PII compliant, or it's required for a business use case or something like that. But you should understand all of the regulations that apply to that data set so that you can make certain that it is compliant. And that then leads on to things like lifecycle management. So this could be making sure that we keep the data for a minimum amount of time. There's quite a lot of regulation that require you to keep data for 5 or 7 or 10 years. The medical industry sometimes is 25 or more years. Or you might have a requirement that you delete data after a certain time. So if the data is over a year old, then we need to age that out. And that would be part of the processing of the data set. And it wouldn't necessarily be shown to the outside world. The consumers of the data are just going to get that data all lifecycle managed and complete. But it would be a part of the data contract and part of the compliance. So data transformation is obviously a part of the data set. So when we ingest raw data, we don't tend to do any transformations against it. That doesn't mean it's different than any of the other data sets on your data lake. It just means we haven't transformed it yet. So while we might say that one of the attributes of this data is that it's raw, it's not transformed in any way, we've not manipulated it, we've not changed even the format of it, those are just attributes, but it's still the same kind of a thing as fully processed and modeled data. So for each data set, we need to understand what those data transformations are. And in some instances, you might also want to record those in the data contracts so that people trust the data, so they understand, if I'm getting this data from Amazon, from a kind of storefront, and it's a really high resolution because they collect loads of data, but then if I strip some of that resolution out because I need to merge it with data from some other store, then if I'm telling my consumers that I've done those things and the reason why I've done those things, then that's fine. But if they're looking at the data and thinking, well, that's not as good of a resolution as the source data, so I don't really trust it because I don't know why that's happened, then you can get issues. So recording those, putting them in the data contracts so that everyone understands what it is. These things also can then live in your data catalog so that people can understand, there's a raw version of this data that's this resolution, and then there's a processed version that's this resolution, and I can choose between those two and decide which one is actually useful to me right now. And then finally, we've got access control. So who gets access to this data? And generally in a data lake environment, for the development side, you're going to have the people working on the project. They're going to get access to the data. Normally they would get it through something like a key vault. So instead of actually giving the end user who's doing the development access to the data lake, their project would request access. That's going to live in a key vault. The DevOps process is going to get access to that key vault while you're developing. But that's generally going to be a read-only access for development purposes, so you're not able to do any harm to the lake. But then when you move on into production, there might be different access controls. And again, normally within the lake, the access controls are going to be machines are going to be doing stuff, automating things, doing transformations, and then writing out to another location. And then when you get closer to the presentation layer, if you've got a lake store, then those sorts of things are going to have access to end users who might have a good reason to access the data. But that access control is tied to the data set rather than to the data lake. So again, that's something that we're encapsulating within this concept of a data set. And so the kind of how this looks, I've drawn this diagram up just to kind of explain the concept. Everything that we're seeing here is a data set, and where we're talking about having the layers previously, we've got the green on the left is the raw data sets, and then the bottom blue box is a single data set where we've kind of done some processing, written it to disk, but then we've done more processing and created a final data set. If there are no consumers for the transitional data set, there's no reason to consider that to be an actual data set of its own. It's just sort of transitional data, temporary data, if you like. that we need for the data set that we're working on. So those layers kind of can exist within a data set. If you just need to do them for processing purposes, then you could just create a folder within your data set and call it transitional data, dump some stuff down, do more processing, and then create your data set from it. But there might be a time when a second data set is consuming that transitional data. And at that point, you might decide, actually, that was part of this pipeline just to create this one data set, but it's now got wider uses. Two people need the same thing, so maybe we'll pull that back out and just call it a data set of its own. And then at that point, it's going to get its own attributes. It's going to get its own access control. It's going to get its own compliance, its own performance, its own data contract, all of those good things. And at that point, it becomes available to people. It goes into the data catalog as its own thing, and people start to access it. So hopefully that explains why you would want to use a dataset encapsulation kind of technique for your planning, so that you can concentrate on a single thing at a time, work out all of the attributes of it, work out the performance and how quickly you can get that from A to B, do all of the processing, and keep it as one thing, so that when you're working on it, you know you're working on just that thing and you're not affecting anything outside of it, because you're sticking within that contract with the outside world. If you're changing that contract, then you might fork off and make a second data set with roughly the same data, but then you can still support the old data set and the new data set and cater to two different sets of users. And this can be really powerful when you're planning and working on your data lake, just to reduce the complexity, reduce the time to delivery of each of these data sets. So hopefully you enjoyed that video. If you did, again, hit the subscribe button below, whack that like button, and I will see you for the next video soon. Thanks very much.